All right, let's talk about science. We see that word everywhere, but what does it really mean when something is scientific? Today, we're going to dig into a huge misunderstanding about one of the most important tools we have for figuring out the world.
So let me ask you something straight up. You see a headline, right? It starts with, "Scientists say." What's your first reaction? Do you just think, okay, that's it, case closed, that's a fact? But is it? Is science really always 100% correct?
It's a super common idea. A lot of us kind of picture science as this giant, dusty book filled with unchanging truths. But that's a myth. And today, we're going to pull that myth apart and look at what makes science so powerful. And it's not what you think.
Okay, first up, the myth of perfect science. Let's really get into this whole myth of certainty. Think back to school. We learned a ton of scientific facts, right? But the way we're taught can accidentally give us this idea that science is all about absolute black and white answers with zero room for doubt. But here's the thing. Real scientific thinking isn't about having a book of final answers. It's a process. It's all about building models, coming up with hypotheses, and then testing them to understand how the world works. And get this, a huge, crucial part of that whole process is actually dealing with, and sometimes even embracing, uncertainty.
So if science is a process, where did we get this idea of the perfect all-knowing scientist? Well, it's not just one single thing. It's actually a mix of a few different factors that, over time, kind of build up this false picture.
We can pretty much boil it down to four main culprits. First, how we simplify things for school. Second, how the media and press releases can blow things out of proportion. Third, just how our own brains work. We love simple answers. And finally, there's a real gap in how scientists and the rest of us talk to each other.
All right, let's start with schools. To make really complex ideas easier to grasp, teachers use models. You remember the atom model that looks like a mini solar system, right? The problem is, we're often not told enough that these are just, well, models. They're simplified sketches, not perfect photographs of reality. And that key detail, that all models have their limits, that just gets lost in the lesson plan. Okay, next up, the news. This is a big one. You have a scientific paper that's super careful with its language, saying things like our data suggests a possible link. But by the time it becomes a headline, it gets morphed into something like scientists prove X causes Y. The caution is just gone.
And here's a classic media move, mixing up relative and absolute risk. A headline will scream at you, eating this food doubles your risk of something terrible. That's the relative risk. But they often leave out the absolute risk. What if your risk was already like 1 in a million? Doubling it just makes it 2 in a million. Yeah, it sounds super scary, but the actual real-world impact is teeny tiny.
And let's be honest, we're part of the problem too. Our brains are just wired this way. We have these things called cognitive biases. We love simple, certain answers. We actively look for information that confirms what we already think. It's just more comfortable to believe in a simple, solid fact than to wrestle with a messy, uncertain reality.
And last but not least, there's this communication gap. Let's face it, most of us don't hang out with scientists every day. So when an expert does get on the news, we tend to hear their statement as the final, absolute truth. We miss all the background noise, the debates, the long process, and all the uncertainty that went into reaching that point.
Okay, so that's the problem. But what do we do about it? It's not enough to just say, hey, this is broken. We actually need to build a smarter society, a better environment for scientific thinking. And that means we need some real, concrete solutions.
And a great place to start is with education. Here are a few steps. 1. Let's teach uncertainty. Make it clear in class what the limits of a model are. 2. Let's analyze pseudoscience. Sometimes the best way to understand what science is to look at what it isn't. 3. Let's get kids asking their own questions, designing their own experiments. And 4, and this one's huge, let's train teachers to be amazing communicators, especially when it comes to explaining that tricky concept of uncertainty.
But this has to go way beyond the classroom, right? The real goal here is to build a whole societal system, an infrastructure, if you will, that actually supports learning for your entire life. We want to make it normal and easy for anyone to engage with science, not just when you're in school.
Which brings us to you and me. Because at the end of the day, this isn't just about what big institutions should do. It really comes down to a shift in our own mindset and seeing how each of us fits into this whole picture.
And this really cuts to the core of it all. The most important thing any of us can do is to just keep learning for our whole lives, to stay curious, to never stop asking questions.
So if there's one thing to take away from all this, it's this.
Let's stop thinking of science as some finished book of facts. Instead, let's embrace what it really is, a dynamic, sometimes messy, but always fascinating process of asking questions. You see, science's true power isn't that it's always right. Its power is that it's always trying to get less wrong. It's always questioning, testing, and improving itself. So, I'll leave you with a little challenge. The next time you see one of those big, flashy scientific headlines, what's one question you're going to ask yourself to dig a little deeper, to get past the hype and closer to the real science? Something to think about.